Welcome to The Explainer. So today, we're going to talk about paradoxes. But listen, we're not talking about those frustrating brain teasers that just give you a headache. No, we're going to look at them for what they really are. Incredibly powerful tools that force us to tear down our understanding of reality and build it back stronger.
Imagine this. You've built a perfect system, right? A flawless machine for making sense of the world. But then, you find one single question, just one, that makes the entire machine grind to a halt, sparks flying. What do you do? And believe me, this isn't just some thought experiment. It's basically the entire story of human knowledge.
You see, a paradox isn't just a clever riddle. It's a stress test. It's like this giant flashing red light on the dashboard of our logic, screaming at us that one of our fundamental assumptions has a hidden bug. And finding that bug is how we upgrade the whole system.
So let's dive right in with our first stress test. We're heading into a realm that's supposed to be perfectly clean and orderly, the world of pure logic and mathematics.
Okay, the setup here is beautifully simple. We've got a village, and in that village, there's a barber. And this barber has one very, very strict rule. He shaves every man in the village who does not shave himself. And that's it. He only shaves those guys. Seems totally straightforward, right?
But this is where the system breaks. Just think about it for a second. If the barber shaves himself, well, he violates his own rule. He's only supposed to shave people who don't shave themselves. But if he doesn't shave himself, then he suddenly fits the exact description of someone he must shave. It's an impossible loop. He's trapped by his own logic. Now, I know what you might be thinking. This is just a silly word game, who cares? But when this idea was formalized as Russell's paradox, it sent an absolute shockwave through the world of mathematics in the early 20th century. It proved that the very foundations they were building everything on were completely unstable.
So here was the real problem. The old rules of math basically said you could define a group of things, what mathematicians call a set, based on any property you could think of. You know, the set of all blue things, or the set of all sets that don't contain themselves. That last one is the problem. The paradox showed this freedom leads to a complete logical collapse. So the breakthrough was to invent a new, much stricter system. It says, hey, you can't just invent sets out of thin air anymore. You have to build them carefully from other sets you already know are safe. This paradox literally forced them to build a stronger foundation for all of modern mathematics.
Now, let's watch that exact same pattern play out again. We're moving from the clean, abstract world of logic to the completely bizarre world of physical reality. Our guide for this strange trip? Erwin Schrödinger and his very famous and very unfortunate cat.
Okay, so here's the diabolical setup Schrödinger dreamed up. You have a sealed box. Inside, there's a single radioactive atom. Now, quantum mechanics says that tiny atom exists in a state of superposition. It's both decayed and not decayed at the same time. Its fate is then linked to this chain reaction: a Geiger counter, a hammer, and a little vial of poison. If the atom decays, the cat dies. If it doesn't, the cat lives. Simple enough?
And this is where reality just seems to melt. Because the cat's fate is tied directly to that quantum atom, the cat itself inherits that fuzzy, undecided state. It's not a matter of us not knowing if the cat is alive or dead. The theory says the cat is literally both alive and dead at the same time, existing only as a wave of possibilities, until an observer opens the box and forces reality to finally make up its mind.
Now this is a really important point. Schrödinger didn't actually believe this was happening. He was doing the exact opposite. He created this whole scenario to basically say, look how ridiculous your theory is when you scale it up to the real world. A cat can't be alive and dead. Clearly, your theory is missing something.
So this paradox forced physicists to really wrestle with this measurement problem. Some argue that a conscious observer opening the box is what solidifies reality. Others propose something even wilder, that the universe literally splits in two, one where the cat lives and another where it dies. But the modern understanding is something called decoherence. It suggests that a big messy thing like a cat is constantly being measured by its environment, by air molecules, light, and heat. This interaction forces it into one state, alive or dead, almost instantly, long before we ever get to the box. The paradox pushed us to finally understand that boundary between the weird quantum world and our everyday world.
Okay, we've tackled logic, we've wrestled with physics, now let's bring it all home, with a paradox that attacks something we think we understand completely, our own identity.
This is the classic paradox of the ship of Theseus. Imagine a famous, historic ship. As its old wooden planks begin to rot, they're replaced one by one with new ones. Years go by, and eventually, not a single one of the original planks remains. So the question is simple, but it's incredibly profound. Is this still the ship of Theseus?
And just when you think you might have an answer, the philosopher Thomas Hobbes adds a brilliant little twist. He says, okay, what if someone collected all those old discarded planks and then used them to build a second ship? Now you have two ships. Which one is the real ship of Theseus? The one in the harbor with the same structure but all new parts, or the one made of all the original material?
And here is why this matters to you. Your body is doing the exact same thing, right now. Over about 7 years, nearly every single cell you're made of gets replaced. The physical stuff that makes up you is almost entirely different from the you of a decade ago. So, are you still the same person?
See, this paradox forces us to decide what identity even is. Is it our physical matter? Because if it is, we are literally a new person every few years. Is it our structure, our pattern, or is it something less tangible, like the unbroken chain of our memories and consciousness? There's no single easy answer, but the puzzle forces us to build a much more sophisticated, durable idea of what it means to be a self.
So what is the point of all these mental gymnastics? It's simple, really. In every single one of these cases, the crisis created by the paradox led directly to a major breakthrough.
The Barber paradox didn't just break math. It forced us to create a stronger foundation for it. Schrödinger's cat wasn't just a weird thought experiment. It pushed physicists to really figure out that line between the quantum and the classical worlds. And the ship of Theseus doesn't just confuse us. It forces us to build a more resilient idea of who we are.
And this is the core idea, right here. Paradoxes are the fault lines. They are the cracks in our understanding. And that means they're not failures, they're maps. They show us exactly where our knowledge is weak, and they point the way to where the next great leap needs to happen. They are the engines of progress.
So, I'll leave you with one last thought to chew on. We know there are billions of Earth-like planets, just in our galaxy alone. The universe has had billions of years to cook up intelligent life all over the place. So, where is everybody? This great cosmic silence, the Fermi paradox, it might just be the biggest intellectual stress test humanity has ever faced. What hidden flaw in our understanding of life, or intelligence, or civilization does it reveal? Now that's a question worth pondering.